Kia ora. We're having a look at page 22. I should probably stop showing you that and just take the fact that you probably believe me. We're looking at page 22 of our Walkermaths books. So I'm just going to do a walkthrough. Okay, the mean distance jumped in a school-long competition was 170 centimeters. You know what? I'm chucking it in straight away. Boom. Draw this. Mean equals 170 and it's centimeters. With a standard deviation of 15 cm. I'm even going to chuck that here. Equals 15. Calculate the probability that Jack jumped between 170 and 200. So now it's a shading game. So 170, where is that? Well, actually that is the mean, which is very convenient and makes this the easiest type of question to answer. And 200 centimeters. Now 200 centimeters is going to be, you don't really need to worry about placement, but I'm just going to be really particular with this one. See how the difference is 30 centimeters and the standard deviation is 15? That means it's going to be 2 standard deviations away, which is 2/3 of it. Just means that it's going to be like nice shading. So yeah, it doesn't really, you're not going to get marked on doing that, but it's going to be helpful in the future if you learn how to do that ratio for some of like the merit excellence questions. So we're just going to shade that in. So between 170 and 200. Ooh, we should probably follow the steps they're giving. I didn't actually check that beforehand. So step 2 is calculate the Z value. So to find Z values, I'm going to do step 2 up here. So a Z value is calculated using X minus mean over standard deviation. Okay, so what is the X value we are interested in? It's this one here. Right, this here is our X value. So I'm going to try and fit in an X equals 200 just there. Right, because now we've got all the details we need. We've got X, we've got the mean, and we've got the standard deviation. Boom, we can find Z. So little z, right, the equivalent is going to be little x minus 170, which is the mean, over the standard deviation, which is 15. Now, let me get my calculator out to do that. You could just use a calculator app, but I'm going to use this just to show my working out. Okay, so what do we want to do? I'm going to do in brackets 200 minus 170, close the bracket off, over 15. Oh, 2. Cool. So little z is 2. Do they want us to draw a z? Because I feel like we should draw a z. Look up the tables to find the probability. I'm going to add a different step in, guys, because I actually do like to have, because this is X, sometimes it's nice to look at our standardized Z. So the equivalent in Z world is we're looking between 0 and our Z value is here, which is an equivalent of 2. Alright? This here is kind of helpful because it's just going to help show you guys what's actually happening, right? So this is something we can deal with on our Z table. So let's open a table. You could go to the back of your book, and there's a nice table you can use in the back of your book, and that's totally fine. You can use that. It's just probably not nice for me to keep flipping. So I'm going to show you where else you can find it. Let's go here. So all I do is go into Google, type in level 2 formula sheet. Maybe you should type in level NCA Maths level 2 formula sheet will probably be better. So, and then just make sure you get the one from NZQA. This is the exact formula sheet that you're going to get in the exam. So see down here how they give you a standard normal distribution. So we're just going to use that to do our calculations from now on. I just wanted to show you how to find that. Get rid of this jank. Nice. Okay, so notice, what I want you to notice is that over here, what we've transformed X into Z, and I want you to notice that this is exactly what we are looking at up in this picture here. It's between 0 and what our little z value are. So all we're looking for is a z value of 2.00000, right? So all we need to go down is down to 2, here we are, 2.0, and I'm just going to highlight that. And then we're actually looking at 2.00. There's no decimal points on this, so we're just going to go down to the 0 one. So this is our answer. It's 0.0000. 0.4772, right? So this area here is 0.4772. I'm totally not following how the book wants you to do this. I think this is a more logical way though, so it will be more helpful. So we found a Z value first, and then I draw it on, and then I find the probability. So the probability that she jumps between 170 and we're looking at X and 200 is equal to 0.4772. Let's see what else I missed from how they want me to do the book. Okay, so they want us to look up, find the probability, and we found that, and write your answer in context. Oops, you can probably do that. Blah blah blah, Jack, blah 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 blah. What is the probability? To be honest, in NCEA you won't actually get more marks for writing it in context, so I'm not even going to bother doing that. Okay. The average number of ice creams sold each day from a mobile van is 278. This is between 278 and 300. It's exactly the same thing. You're going to put 278 here. It's going to be between that and a 300. It's looking too similar to exactly how I worked out this question, so I'm going to go to question 3. It might be a little bit more challenging. Let's find out. Let's move my camera over. Give me a second to autofocus. Oof. Terrible. Terrible. Dang it. Stop wasting my time, camera. Okay. The average rainfall for a town is 960 millimeters. Okay, this one's a little different. This is how I would do it. I'm going to do my steps. First thing I do is I draw my X, my random variable X, that's the question we're looking at, and right below it I draw my random variable Z, the standardized normal. They should look exactly the same. Draw a line in the middle, both of them, bang, bang. Now, X. 960 is the average. Average is mean, median, and mode for normal distribution. They're all in the middle. With a standard deviation of 22, so we're going to put mu equals that. You could put, I'm going to put it over here because I don't have space down there, my bad, equals 22. Right. Calculate the probability that this town receives between 960 and 1,000. This is just under 2 standard deviations, so I'm going to put it around about here. Shade it in. That's what the calculate the probability that this town receives between 960 and 1,000, which is our X value here, in a year. So they want to know between here and here. We're trying to work out this area. We're going to do the table method, so we have to transform X into Z, where this is going to be a 0. We're going to need to find out what this Z value is here, the equivalent Z value, so we can find this probability on a Z table. In order to transform it, we just go X equals, whoopsies, my bad, Z equals X minus mu over standard deviation. Let's trade them out. So our little Z is going to be, our X value is over here at 1,000. And we're going to minus off the mean, 960. And we're going to do that all over the standard deviation of 22. I'm going to show you another way of typing that into your calculator, just a way that's probably a little bit faster. You can just do 1,000 minus 960, click equals, and then divide by 22. It's the same method as this, it's just a little bit easier to do. So our Z value is coming out at 1.818. Oh, this is a much better question. This is going to be more difficult for us to find a Z value. That's good. Okay, so at this point we don't really need a calculator anymore. We do need this, and we want to have a look at this. Cool. Okay, so we're trying to find the Z value of 1.818. And I want to make this really clear what we're going to do here. We're going to look for 1.8. It's going to be row 1.8. The row is going to be 1.8. Column is going to be this 1, and difference is going to be this 8. And I just want to make that clear because sometimes it's a little bit hard. So the first two, we find it going down here, so we go down to 1.8, so I'm going to color in that row 1.8. Sweet. And then the column is going to be number 1, so it's going to be down here, and that gets us a value 0.4772. 0.4649. So at this stage I'm going to write that down. So I'm going to write probability that it's between 960 less than x less than 1000. You don't need to do this notation, it's just how I like to do it. So we've got this value 0.4649, and we need to add on a difference. See, we've got this difference of 8, so we need to find that and add it on at the end. So we need to go across difference of 8 here, and we're going to have to add on a 0.0006. 0.0006. Now I'm just going to remind you, if the difference column is a single digit, it just fills in the last of, it's the fourth DP. But if it's 2 digits, it's the third and the fourth decimal place. For example, up in this corner over here. Okay, so this one's just going to be, see how it's just a difference of 6. That means we're going to add on 0.0006. So we can do that in our head, or we can do it in the calculator. I find it's more fun in my head, but it's definitely high risk, so probably better to do it on the calculator. 0.4649 plus 0.0006. So the final probability ends up 0.4655. I'm just going to quickly explain that. We found this Z value here, and we found it to be 1.818 using our formula. We then look at this picture here. It is between 0 and Z, just like here, 0 and Z. So this probability, we found it to be 0.4655. And the thing is, these are proportional to each other. So if that's 0.4655, that means this one is 0.4655, right? Because they are proportional to each other. That's why we standardize using this formula, and that means that we find our exact probability. So the probability that the town receives between 960 and 1,000 millimeters of rainfall is 0.4655.